So we're going to look at just sort of a special type of equation that comes up. These actually aren't very difficult, but they do come up from time to time, and since they look different from what we're used to, we're going to spend a little bit of time with them. So most of this video is going to be about algebraic proportions, but leading into that, since algebraic proportions sort of look like they have fractions involved, I want to review some ways that we handle equations that have fractions. Okay, first one here, I have n over 3, but that's a fraction bar, remember, and fraction bar means division, minus 8 equals negative 2. This is a two-step equation. Instead of multiplication over here, which is what we're used to seeing, though, we have this division. So it's the same way. We're going to take care of that minus 8 first, the inverse operation. We're going to add 8 to both sides, and we're going to end up with n over 3, or n divided by 3, equals 6. Okay, now this looks funny. It does look like a fraction, but remember the fraction bar is a division symbol. So this is n divided by 3. The inverse operation to division is multiplication, so we're going to multiply both sides by 3. This also looks a little weird when we're doing this. It just looks different from most of the two-step equations we solve. So whatever we do to one side of the equation, we have to do to the other, so we multiply both sides by 3. So what happens here, this is 3 over 1, right? And this is n over 3. So those 3's, they simplify, they become 1, or 3 over 3, which is 1. 1n is n, and 6 times 3 is 18. Okay, remember with an equation, you can take that value, you can plug it back in, you can check it. This would be very easy to do. 18 divided by 3 would be 6. 6 minus 8 would be negative 2. Okay? The next one that we want to review is a fractional coefficient. So the number in front of the variable is a fraction. This is a two-step situation again. I need to take care of the plus 4 first, so I'm going to subtract 4 from both sides. I'm going to get 2/5 x equals 10. This is 2/5 times x. There's a couple of ways you can handle this. You can divide both sides by 2/5, and then you have to divide by the fraction, or you can go ahead and take care of that now, and what you can do is multiply both sides by the reciprocal. So instead of 2/5, you'll multiply both sides by 5/2, okay? And the reason you do that, a number times its reciprocal is always 1. So look what happens here. 5 times 2 is 10, 2 times 5 is 10. This would be 10 over 10, which is 1x, or just 1. So those will simplify to 1, and you're left with x. And then over here, you would put that 10 over 1. 2 goes into 10 5 times. 5 times 5 is 25. So don't let the two situations here confuse you when you see them. All right, now this next one. This also tends to confuse people a little bit. I have addition, I have division. Most people say, well, when I'm doing an equation, I take care of the addition or subtraction first. That's true, but this time, this x plus 13 is all over 12, and the fraction bar, the division bar, is a grouping symbol. So that x plus 13 is really in parentheses. You can't do anything with it until you free it from this fraction bar. So this is divided by 12. So I have to, first of all, multiply both sides by 12. So these 12s are going to simplify. They're going to become 1. We're going to be left with x plus 13 equals 1 times 12 is 12. Then, once we're free of the big old fraction bar up there, this is just a one-step equation. We're going to subtract 13 from both sides, and x is negative 1. Okay, so review that, look at that. Those will come up from time to time. Don't let them confuse you. All right, so most of this video is about proportions though. What is a proportion? This is review. A proportion is two ratios set equal to each other. You've been dealing with proportions since about the 6th grade, and you learned several ways to handle them. But last year in 7th grade, you learn how to use cross products to solve a proportion. That's sort of the algebraic way of solving a proportion. So that's what we're going to do, is we're going to use cross products. So if I have x over 4 equals 3 over 2, Again, there's a couple of ways I could do this, but let's look at it using cross products. I'm going to multiply the terms that are across from each other using an X formation, okay? So you wouldn't go straight across, you go diagonally across. And I end up with 2 times x equals 4 times 3. We won't typically write that step. We'll usually write this next step, 2x equals 12. In this case, it's a very simple one-step equation to solve. We're going to divide both sides by 2, and we end up with x equals 6. And that's sort of what we expected, right? 2 times 2 is 4, so 3 times 2 would be 6. This is just the algebraic way to show that. Now, this is what proportions are going to look like this year. A little more complicated than what you saw as a 7th grader. It's going to be the same thing. We're going to use cross products to clear the fraction bars. So we're going to multiply in this diagonal form the two things that are connected to each other sort of in this x, okay? We need to remember that that f plus 3 is in invisible parentheses, that this fraction bar is a grouping symbol so that f plus 3 goes together up there. So we end up with 2 times the quantity f plus 3 equals 7 times 7. Okay, so I multiplied across this way, I multiplied across this way. The next step is to distribute. You might have 1 or 2 distributive property to take care of, and we do here. So 2 times f is 2f, 2 times 3 is 6, and of course 7 times 7 is 49. Now you have an equation to solve. This is no big deal. I'm going to subtract 6 from both sides. I get 2f equals 43. I'm going to divide both sides by 2, and this one, 43 over 2, 2 does not go into 43 evenly, so I will either leave it as 43 over 2, remember that improper fraction is okay, or since I get a terminating decimal, I can write this as 21.5. Okay? Alright, so on these two, if you want to pause the video and try both of these and then check your work, that'll be great. This is a good time to see if you know what's going on. Otherwise, I'm going to talk through both problems having already worked them out. You make sure you get all the steps down and show me how you get from one place to the other. Okay, so y minus 3 over 2 equals y over 5. So I did 5 times y minus 3. Notice I put the y minus 3 in parentheses, and then I did 2 times y. I had distributive property over here. 5 times y is 5y. 5 times negative 3 is negative 15. Now for this one, I ended up with a variable on both sides, right? Now if we use our general rule, I have a coefficient of 5 and a coefficient of 2. So that's the smallest one. I subtracted 2y from both sides. So 5y minus 2y is 3y. Bring down the minus 15 equals 2y minus 2y is 0. And this is one of those times I have to write it, right? Because there's nothing else over here. This is a case, let me just mention this briefly. If you had wanted to move the 5y by subtracting 5y from both sides, you wouldn't end up with this 0 here. You would just have an extra negative to deal with, but as long as you're careful, that's no big deal. So now I have 3y minus 15 equals 0. I added 15 to both sides. I divided both sides by 3, and I got y equals 5. Okay, so these aren't that complicated as long as you get the cross multiplication correct. Let's look at the next one. So I multiplied 5 times the quantity 2k minus 3. Notice I put it in parentheses. And 3 times the quantity k plus 9. Notice I put it in parentheses. I did distributive property on both sides. No big deal there. I have a variable on both sides of the equal sign. Nothing to simplify or combine like terms, so just moving the variable. I moved my lower coefficient, so I subtracted 3k from both sides. 7k minus 15 equals 27. Nice, simple two-step equation. I added 15 to both sides. I got 7k equals 42. I divided both sides by 7, and I got k equals 6. So these are the different ways that fractions can show up in an equation specifically algebraic proportions, but we also looked at those others. Now we're ready to practice with them in class.